So today I will be talking about a strategy. It's a note-taking or learning strategy that is known as a visual glossary. The method to this is to get the key vocabulary terms of whether you're doing mathematics, history, or language arts. In this case, we'll be talking about it referring to mathematics, more specifically geometry. So basically, you start off by putting the key term here. Okay, I will be showing examples shortly. Then you put the word for word definition in this quadrant and a picture. You have the students draw a picture here in which they can relate to the definition. Most of the time, because it is geometry, you want to draw the most basic image you can find referring to the key term. Okay, the next square is keywords. Okay, here you put the keywords, or you have the students put the keywords in which helps them remember that definition of the term you are referring to. Okay. Next is notes. This is anything, and it's open to interpretation, anything that the students can have on there, anything that's going to help them remember. The keywords was referring to the definition or the specific process, and the notes is something which it could be a short sentence, even another picture, anything that helps them, anything that triggers their mind. Okay, so just you can see a bigger picture. Usually you can fit about 4 in each paper, and you make it double-sided so you have 8 definitions into one sheet of paper. Okay, so I had a couple students draw some images on these, and we'll start off with the first one so you can see it. It's the surface area of a cone. Okay, so you see the student put the word for word definition, the surface area, etc. Then the student basically drew the picture of what was in the theorem or the glossary, whatever they may have found this image from. Okay, it's a basic cone with the radius and the length. Okay, the length of the height. In this case, the key words for this specific student was the area of a circle, which over here is a pi r square, and it's one of the more common definitions or equations that we use. So I'm assuming that's why he just put it. He knows it, and then he just put the area of a circle plus pi times radius times slant, which we can see the radius and the slant are up here. Okay, for notes, he wrote out the long process of the area of a circle and basically just copied it over this way. Okay, and he did write a note here, and it says answers almost always include the pi. I'm assuming what he's referring to is when we find a solution, we always see a pi. They never actually multiply by 3.14, and it's just maybe to avoid certain problems or issues with decimals. But that's something he noticed, and he feels comfortable writing. I'm assuming he may have seen it more than once or commonly used, so he decided to include it. Okay. Another example right next to this one was a girl. I had her write it, one of my girl students write this in. Again, in this case, we're talking about the volume of a cube. She drew a little cube on there. Okay, the volume of a cube is a cube of length of its sides, or V equals S cubed. Okay, seems again she did take the standard definition of a cube. Okay, so in this case, a cube, the volume equals 100 feet cubed. So she wrote x feet, which is the length, of all sides. And keywords. For keywords, she put the cubic of the length of its side. So basically, the example that was up here of having it of 100 feet cubed, we see it here. Okay, so we see V equals S to the third, which is our standard equation, which we can see here. And you plug in the values, and after you cube 100, she came up with the answer of 46. Okay, so notes. We'll see the notes she put was example is working backwards. Cube always means to the power of 3. Okay, equals x cubed, x to the third. Okay, so one thing we see a lot of students struggle with is when you say square, when it's 2 times 2, a lot of times they'll think it's just, for example, if we take the number like 10, instead of 10 times 10, we'll see 10 times 2, and a lot of answers you'll get 20. So I'm assuming that's why she put this here, It always means cubed to the third, so she won't get it confused. She'll know what that means, to what power. So cube automatically means to the third power, and she wrote it on here. Okay. One of the important parts about this is that it's specific to interpretation. Actually, students do have a specific requirement to meet when filling these out, but at the same time they can write whatever helps them remember. I mean, we can give them one certain strategy or another. This one, I feel it encompasses the visual learner, and maybe even definitely an ELL student, because it gives them a chance to kind of break up the definition rather than just writing it word for word, as we commonly see that they just write it like this and that's it. Including an image will give them something to relate to for those visual learners, and those ELL students will have something to see. Okay. Many times, especially when dealing with geometry, you want to use manipulatives as well, which always helps students with vocabulary issues. Okay, so I hope you have liked the visual glossary. Again, you can change it as you please. Maybe in the notes you can require them to do something specific, write a sentence of anything, but more than likely you'd want to leave it to their interpretation, because it is them who are learning the definitions, and it is their visual glossary that they'll be putting together. This is also good for letting them use, if you see that they're struggling, you let them use it for their unit test, unit exam, whatever it is, how your school functions, and it gives them a reason to want to fill it out. Many students sometimes, as much as they like it, don't want to go through the drawing process, or just a breaking down of the vocabulary words, but giving them incentives, I've noticed that it does tend to help, and a lot of students actually like it. It's something different from the traditional write the vocabulary words down and learn them. Okay, this gives them a different method towards learning them, and they have the pictures and an example right in front of them. Okay, one thing referring to examples, here you can put keywords and also says example. Okay, like this student here, she put the example of what we saw up here. Okay, making it easy for her to relate the two problems directly. On this side, we just saw the notes. He didn't use an example, but nonetheless, again, it's open to interpretation. Okay, so again, I hope you have liked it, and thank you very much for watching this video.